Hi class, so this week we're continuing with chapter 12 and we're going to cover t-test. Just a review from last week with hypothesis testing, that it is a testing of relationships between two or more variables, and statistical tests are used to find the probability that the relationship between variables is due to sampling error or to chance. Again, the null hypothesis is always that there is no relationship between two variables. Then you can have a two-tailed hypothesis where there is a relationship, but there's no specific direction of the relationship. One-tailed hypothesis would mean that there is a direction. So depending on what you're looking for or what you're testing, you would either use a two-tailed or one-tailed hypothesis. And again, very important to remember the p-value, that whenever you run a statistical test, that if you get a 0.05 or less, that means that there is statistical significance and that you would reject your null hypothesis and accept the alternative, because you can show that there is a relationship between the variables, and your null hypothesis is basically that there's no relationship, and so you would reject the null and accept that there is a relationship between the two if your p-value is less than or equal to 0.05. All right, so when it comes with t-test, t-test is basically testing mean differences. There's three different kinds of t-tests. The first one is an independent samples t-test. With the independent samples t-test, it compares the means of two independent groups. So each member of that group can only belong to one of the categories of the nominal level variable. So for example, if you have the variable gender, right? So that means you would have two groups. And if you wanted to see if there is a difference, or if you wanted to see if there's a mean difference between male and female, that would mean that you have two separate groups, and that would mean that male can only be a part of the male group, female can only be a part of the female group. So you can't have female in your male group and male in your female groups, right? Each member can only belong to one category. So with paired samples t-test, this is also known as your dependent samples t-test. So this one measures the changes in the same individuals at 2 points in time. So a perfect example of this would be when you use a pretest and a post-test. So the same group that takes the pretest is the same group that's taking the post-test. So you're basically surveying the same group of people twice at 2 different points in time. With a one sample t-test, this one estimates the likelihood that a single sample comes from a given population. So here you're testing whether a group of children in a specific neighborhood had health problems similar to children their age in the population. Okay, so just one sample. We generally mostly use your independent samples and your paired samples. For your actual homework, you'll have a homework on independent samples, and you'll also have a homework on paired samples. So we're going to concentrate on those two. So with your independent sample t-test, you can have a question like, do two independent samples belong to the same population? Is there a difference in satisfaction between in-person and telephone interviews? So when looking at the question, is there a difference in satisfaction between in-person and telephone interviews? You're looking at two separate groups, right? You're looking at the ones that are doing in-person, and you're looking at the ones that are doing telephone interviews. So you're not looking, they're independent samples because that means that the in-person would be separate from the telephone. So if you are doing telephone interviews, you're not doing in-person interviews. So you're independent, the groups are independent of each other. And let's see. So looking at the results, the way you would report your t-test, you would have the t, your t statistic, and then you'll have your degrees of freedom here. So if you follow the arrows, it shows you degrees of freedom, which is 340. Your t statistics is the 1.338. And then your p-value, which is 0.18. So here, remember, your p-value has to be 0.05 or less to be significant. And so since our p-value is greater than 0.05, we say that no, there's no difference, right? So we can conclude that no, those interviewed in person have equal satisfaction as those interviewed by phone. So there's no difference in satisfaction between those who completed their interviews in person versus those who completed telephone interviews. That's because our p-value is greater than 0.05. Okay, so those are the pieces of information you're going to need for your t-test. You're going to need the t-statistic, which is 1.338. You're going to need your degrees of freedom, which is right here, 340. And then you're going to need your p-value. Okay. All right, for your pair sample t-test. So maybe you're looking at, are independent samples different over time? Here's an example. Are computer skills different for foster youth from pre-test to post-test? So we're looking at whether computer skills were any different for foster care youth when they first took the survey at pre-test versus when they took it after intervention at post-test. So again, remember, we are looking for your t-statistic, which is the 6.152, and that's a negative 6.152, goes right here. We have a degrees of freedom, which is, let's see, where's my degrees of freedom? Okay, right here, 36 is my degrees of freedom. And then my p-value is 0.000. So is 0.00 lower than 0.05? Yes, so that would mean that there is a mean difference. So that would mean that, yes, there is a difference between computer skills from pre-test to post-test. So skills have improved, okay? And because our p-value is less than 0.05, that means that it's unlikely that it was caused by error or chance. Then the one samples t-test we're looking at is a sample mean different from a population mean. So an example of this would be, does this group differ in IQ scores from national norms? Okay. Again, t-statistics is 1.847, our degrees of freedom is 9, and then our significance level is 0.098, or basically if you round that off, it would be 0.10, so that's definitely higher than a 0.05. So we can conclude that there is no difference in IQ levels. And remember, if you see significance, two-tailed, significance basically mean your p-value. So it may not say p, but if it says significance, SIG, that is still talking about your p-value. All right, so how do you report your t-test? So as you can see, your t-test or your t is reported with the little t. You need your degrees of freedom, which is calculated by n-2. And you also need the probability that results are due to sample, or basically means that we're looking for the probability that your results are due to sample error or chance, your p-value or your p. And so here's your n, that would be like your sample size. T would be your actual t-statistics. P is your p-value. So an example here would be your t, 44 is your degrees of freedom. 1.23 is your actual t-statistic, and then your p-value is 0.09, which is higher than 0.05. So that would mean that there is no difference between whatever relationship you were looking at. So with your independence group, the university students taking statistics courses and psychology had higher IQ scores than those taking statistics courses and statistics. So when reporting t-tests, we also have to report our mean because we're looking at mean differences. And when we report our mean, we also have to report our standard deviation. So the mean score for psychology students was 121. Standard deviation was 14.2. The mean score for statistics was 117, standard deviation 10.3, and then we report our actual T. which is T44 equals 1.23 and our p-value of 0.09. So these are the things that you would need for your actual t-test results. With the dependent samples, same thing. We do have to report our mean and standard deviation. So results indicate a significant preference for CBT, and we report our mean and standard deviation over psychodynamic, mean and standard deviation, and also our actual t-test results. Same thing for the one sample. So those are just some general examples of how to report your t-test results. Those are the main things that you need to make sure you include. You have to include your mean and standard deviation, and you also have to report your actual t-test. So it just gives you kind of the format of what it should look like or how it's reported.